Can humans really turn one element into another? For centuries, alchemists obsessed over transforming base metals like mercury into gold, a quest that was as much spiritual as it was material. The laboratory was their temple, every experiment a step toward enlightenment. They sought the Philosopher's Stone, a mythical catalyst for both gold and immortality. But their tools were crude, their understanding of matter limited. They didn't know about atoms or protons. Despite endless experiments, the dream eluded them. Yet their failures laid the groundwork for modern chemistry, leading to discoveries and techniques we still use today. Science moved on, defining elements by their unchangeable number of protons. The alchemist's quest became a cautionary tale, until now. What if they were simply ahead of their time, and today, we finally have the tools to achieve their impossible dream? Gold has shaped empires and driven humanity to the ends of the earth. Alchemists hoped to shortcut the brutal quest for gold with a blend of early science and mysticism. They believed metals were made of two principles, mercury and sulfur, and that gold was their perfect balance. But the real difference between mercury and gold is just one proton in the nucleus, something no chemical process could change. Only nuclear forces can alter an atom's identity. In the 20th century, scientists finally achieved transmutation in particle accelerators, even turning bismuth into gold. But the process was wildly expensive and impractical. The alchemist's dream was realized, but only as a scientific curiosity. The dream of making gold remained out of reach until the nuclear age. Now the question is, can we do it at scale? Today, the ancient dream of Chrysopoeia, the quest to turn base metals into gold, is being revived. But this time, it's not with spells or mystical stones, but with the cutting-edge science of nuclear fusion, a technology that was once the stuff of science fiction. Marathon Fusion, a pioneering U.S. engineering firm, claims we can now turn mercury into gold, not just in tiny amounts, but economically, and at a scale that could change industries. Their approach is attracting attention from scientists and investors worldwide. The secret isn't a mythical philosopher's stone, but the same process that powers the sun and all the stars in our universe: fusion. By harnessing this immense energy, we can achieve what alchemists only dreamed of. This isn't about making a few atoms in a lab for curiosity's sake. It's about producing gold by the ton, potentially revolutionizing the global gold market and the way we think about precious metals. Fusion's promise is twofold: limitless clean energy for the world, and as a remarkable byproduct, the creation of precious gold. It's a combination that could reshape both the energy and materials industries. The idea is to use the high-energy neutrons released from fusion reactions to transmute mercury atoms into gold, a process that was once thought impossible outside of stars or supernovas. If successful, the process could make fusion power plants dual-purpose facilities, generating both electricity and gold, maximizing their value and impact. This breakthrough could transform the economics of fusion, making it more commercially viable and accelerating its adoption worldwide. It could spark a new era of innovation and investment in clean energy. The alchemists of old sought gold for personal wealth and glory. Today, we seek it as a means to power a sustainable, cleaner future for everyone. The fusion solution is a radical, science-driven vision of alchemy, one that could finally fulfill humanity's age-old dream, not through magic, but through the power of physics. Could this be the breakthrough that changes everything, ushering in a new golden age for science, industry, and the planet? Inside a fusion reactor, like a tokamak, the process begins with a powerful magnetic field that confines a superheated gas called plasma. This plasma is made from hydrogen isotopes, which are the building blocks for fusion energy. These hydrogen isotopes are fused together at temperatures even hotter than the core of the sun, reaching millions of degrees. At these extreme conditions, the atomic nuclei overcome their natural repulsion and merge, releasing enormous amounts of energy. This fusion reaction releases high-speed neutrons, which are uncharged particles that carry much of the reaction's energy outward from the plasma. These energetic neutrons escape the plasma and slam into a surrounding blanket that lines the inside of the reactor, transferring their energy and initiating further reactions. Traditionally, this blanket is made with lithium, which not only absorbs the neutron energy to generate heat for electricity, but also breeds more tritium fuel, making the process self-sustaining. Marathon fusion proposes a new twist, adding a stable mercury isotope, Mercury-198, to the blanket. This innovative approach opens up new possibilities for what a fusion reactor can achieve. As neutrons bombard the mercury atoms, they trigger unique nuclear reactions that can change the atomic structure of the mercury itself. These reactions can transmute mercury into entirely new elements, including precious metals, by altering the number of protons and neutrons in the nucleus. The reactor becomes a nuclear forge, not just generating power, but also enabling transmutation. The process is elegant, using the same conditions that produce energy to create new materials. The very same neutrons that drive energy production can also create gold and other valuable elements, turning the reactor into a dual-purpose machine. This dual-purpose design could revolutionize both energy and material production, making fusion reactors far more versatile and economically attractive. The fusion reactor, once just a power plant, now has the potential to become a source of rare and valuable materials as well. In this way, it could become the modern alchemist's workshop, where the ancient dream of turning base metals into gold is realized through advanced science. It's a leap from mystical symbols and secret recipes to the precise laws of nuclear physics, where transformation is guided by knowledge and technology. The dream of alchemy is reborn, this time with science leading the way, unlocking new possibilities for the future. The recipe is precise. Start with Mercury-198, a stable isotope, carefully measured and placed in the reactor's blanket. This step is crucial, as only Mercury-198 will respond to the process in the desired way, setting the stage for a remarkable transformation. Inside the fusion reactor, high-energy neutrons are unleashed. These neutrons collide with the Mercury-198 atoms, knocking out a neutron and converting them into Mercury-197. This is a delicate dance of particles, orchestrated by the intense environment of the reactor. Mercury-197, now unstable, doesn't last long. It quickly undergoes electron capture, a process where an electron is absorbed by the nucleus, turning a proton into a neutron and changing the atom's identity. This nuclear alchemy transforms the atom into gold-197, the only stable, naturally occurring isotope of gold and the very same element that has fascinated humanity for millennia. The process is surprisingly efficient. Within just a few days, a significant portion of the Mercury-197 decays into gold, making the transformation not only possible, but practical on a laboratory scale. After the nuclear reactions are complete, the newly formed gold can be chemically separated from the remaining mercury using advanced techniques to ensure purity and safety. What once took alchemists years of trial and error, guided by mysticism and hope, now happens in less than a week, guided by the precise knowledge of nuclear physics and modern technology. This is transmutation made real, not by magic or wishful thinking, but by the predictable, testable laws of nature, harnessed by human ingenuity. The ancient dream of the alchemists is finally achieved, not through secrecy or superstition, but with scientific precision and transparent methods. Gold, once the symbol of perfection and immortality, is now a tangible product of human creativity and technological progress. The transformation is no longer just a metaphor for change. It's a scientific reality, witnessed and measured in the lab. Modern alchemy is here, powered by the energy of fusion, and it's reshaping our understanding of what's possible in the world of matter. The alchemist's philosopher's stone was a myth. Today, the high-energy neutron is the real catalyst. Unlike particle accelerators, which are inefficient and costly, fusion reactors use neutrons already produced for energy. Gold production becomes a valuable byproduct, not the main goal. This approach doesn't drain extra energy or resources, it leverages what's already there. Simulations show gold can be made without compromising the reactor's main function. Fission reactors can't do this. Only fusion's unique neutrons have the right energy. It's as if nature hid the key to transmutation in the stars, and we finally found it. The fusion reactor is the modern philosopher's stone, unlocking the secrets of matter. Alchemy has become science, and the impossible is now within reach. The age-old quest for gold has a new, scientific answer. The economic impact could be massive. A single fusion plant could produce up to 5 metric tons of gold per year. At current prices, that's over $500 million in extra revenue annually. This could make fusion power plants not just viable but highly profitable. The gold revenue could offset construction costs and lower electricity prices, speeding up the adoption of clean energy. Environmentally, this is a game changer. Traditional gold mining is destructive and polluting. Fusion-made gold is clean and contained. We could meet global gold demand without scarring the earth or poisoning ecosystems. Energy plants would become sources of both power and precious materials, with minimal waste. It's a vision of a circular, sustainable economy, where energy and material creation go hand in hand. The promise is not just wealth, but a cleaner, healthier world. As exciting as this sounds, it's still theoretical. So far, only computer simulations show it's possible. The method awaits real-world testing in an operational fusion reactor. Experts agree the physics is sound, but practical challenges remain. Newly made gold would be slightly radioactive and need years of safe storage before use. The biggest hurdle? We still need commercially viable, energy-positive fusion plants. Fusion is one of humanity's toughest engineering challenges, and we're not there yet. Until fusion power is a reality, gold factories remain a dream. Still, the concept is inspiring, a glimpse of what's possible when science meets imagination. If we can make gold, what else can we create? The future may be golden, and the age of alchemy could finally be at hand.